Here we'll do an example of an absolute value inequality. As with an absolute value equation covered previously, our first move is going to be to try to get the absolute value bars by themselves and move everything else away. Therefore, we'll take this positive 7 and move it to the other side. When we move it, it will become negative 7, and we will have x plus 5 inside of the absolute value symbols less than or equal to 12 minus 7, which is 5. Our second step, similar to what we did in an absolute value equation, is that we will now write two inequalities. We will write a positive version and a negative version. The positive version will just be x plus 5 less than or equal to 5, only without the bars. The negative version will have a flipped inequality symbol and will also have negative 5 rather than positive 5 on the right side. Let's write both inequalities now. For the positive version, we'll say x plus 5 is less than or equal to 5. When we subtract 5 from both sides to get the x by itself, we'll end up with x is less than or equal to 5 minus 5, which is 0. This will be part of our answer. Now we'll do the negative version, and we'll have x plus 5 is greater than or equal to negative 5. The less changes to greater, and the 5 changes to negative 5. Still, we will subtract 5 from both sides just as before. We will end up with x is greater than or equal to negative 10. We will use these two inequalities to solve this question. Before we go any further, let's pay special attention to the symbol of the inequality that we started with. We initially had less than or equal to for our absolute value inequality. If you have less than or equal to as part of your original inequality, when we draw on the number line, we are looking for intersection between the two solutions. We'll draw the number line now, placing our points on the number line along with the infinities. Note that our positive version has x less than 0. Let's keep in mind that less than or equal to here means that we will go left from the 0 and also use a closed dot. We'll place the closed dot on 0 and draw an arrow pointing left. Now for our negative version, notice that we have greater than or equal to. This will also be closed, but now we'll draw to the right, starting from negative 10. So we'll place our closed dot on negative 10 and we'll go right. You can see on the picture there is a region where the arrows cross each other, here in between negative 10 and 0. This negative 10 and 0 we'll call an intersection. This intersection is our solution set. Therefore, we will write our solution interval as negative 10 to 0. Because these are closed dots, we will use square brackets on the negative 10 and the 0. If the inequality had been greater than or equal to 5, that would have changed our answer ever so slightly. We would have still had negative 10 and 0 marked, and they still would have been closed circles. However, if you begin with a greater than symbol for an absolute value inequality, what you'll have instead is a divergence. This means that the arrows point away from each other in opposite directions, and there is no intersection. How that would look on the picture is that you'd have an arrow pointing from negative 10 toward negative infinity, and then another arrow pointing from 0 to infinity. So now you have two solution regions, A and B, which I'm labeling now. The part in the middle will not be part of the solution set. When we write A union B, we will have negative infinity to negative 10 union 0 to infinity. Region A going from negative infinity to negative 10, and region B going from 0 to infinity. The infinities will have parentheses, and since these are closed dots, we will use square brackets on the 0 and the negative 10. This would be our solution set for greater than or equal to 5. Here are a couple of special cases for absolute value. Our first inequality is x plus 5 in the absolute value bars plus 7 is less than or equal to 5. Again, let's try to get the bars by themselves and subtract the 7 over to the right. And we'll end up with absolute value of x plus 5 is less than or equal to 5 minus 7, which is negative 2. The issue with this absolute value inequality is that an absolute value can never be negative, and it definitely can't be less than a negative. It doesn't matter what number I put in for x, that absolute value will never be less than negative 2, because absolute value cannot be negative. That means there is no solution to this inequality, and we say D in E. Now we look at the other case. You may notice that the only thing that's changed is that the less than or equal to has become greater than or equal to. Once again, we subtract the 7 from both sides, and we get absolute value of x plus 5 is greater than or equal to negative 2. This is the opposite case, because absolute value is always greater than any negative number. That means no matter what number we put in for x, it will definitely work, because no matter what x is, that absolute value will always be greater than negative 2. Because any x works, we will say negative infinity to positive infinity. So we will say there are infinite solutions. Some people will write this as all real numbers. However, in this class, what we'll write is negative infinity, comma, positive infinity, both with parentheses. This will be our solution set to that inequality. Thank you for watching. We'll see you again soon.